So what we're going to do, we're going to show you some examples by this model of the dangers of electricity out there. So what you see here represents what's really out there on a small scale. And we want to show you how to stay safe around it, okay? Does anybody have a cat at home? You may say, well, I'll never drive a big truck like that. We don't really boat or anything. But see, you've got cats, don't you? Have those cats ever climbed trees before? Sometimes. They do. Ornery little kittens, mostly, they climb trees, don't they? Well, sometimes they get up in trees and they can't get down. Is that right? Well, here's a cat, white with orange spots. And he's stuck up in that tree, and running through that tree or close to it, what's that? Power line, right? Now, just like those lines out on those big poles out there, that's what this is. And as long as my button isn't pushed, I can touch it, okay? We'll be safe. But that cat is up in the tree, and it can't get down. So you say to yourself, I've got to go rescue Muffin. So you start to climb up this tree, and you don't pay attention to what's above your head. And when you get too close to that power line, look at what's going to happen. Ready? Right here. Look at that. He just got shocked. And that is a little more dangerous than static electricity or touching a door handle on a truck. That's very powerful, and it's enough to very much hurt you or even worse. Now, what you need to know about this electricity flowing through those lines is that it wants to get down to the ground. Now, we're not going to tell you exactly why all that is, but just to understand, anybody afraid of heights a little bit? Like climbing on a ladder, maybe, yeah. Well, we're going to say that electricity is afraid of heights, okay? It doesn't like it up here in these lines. It wants to get back down to the ground. And so it's going to use whatever means possible to get out of these wires and back down to the ground. Now, did you see how it happened there? It left the wire and went through that person on down the tree, and it found its way to the ground. Let me give you another example. Watch this. Anybody ever flown a kite before? Yeah, that's fun, isn't it? But let me let you know, it's not fun around power lines because it can be dangerous. It can be a beautiful day, nice breeze, and your kite's flying back and forth. But if while holding onto that kite, it gets into a power line, look at what can happen. Now, you know how it's getting to the ground here, right? Remember, it's afraid of heights. So it wants to get to the ground, and it's traveling out of the wire, down the kite string, and notice how the person's lighting up. How do we usually tell electricity's present? Light bulbs, right? Yeah. And so that's why we've put a light bulb in each one of these people, so we can see that electricity is actually flowing through that person and down into the ground, okay? Let me give you another example as I move this kite string back. This might not be as important for you, but it is for us. For those of us who work on electricity, here's an example of a pole, and you guys may never climb a pole. I wouldn't advise you to try. But sometimes we climb poles, and we have to be careful also of what we call devices on the pole. Not necessarily the electricity flowing through the wires, but it's also in and below these devices. Look at what would happen here. If we climb a pole and we're not careful and we don't pay attention to what we're doing, look at there. That's a big one, isn't it? Now, can you see closely, did he even touch that wire? Let's see again. See if he touches it. He didn't, did he? It got him before he even touched it. You know what that's called? It's called an electrical arc. It's where all these electrons build up in the air and they jump from one thing to another. And that is what's happening here. Now, this electricity flowing through the bottom is just as dangerous as what's through the wire. So that cat, it's probably going to have to stay there until the power company gets there to turn the power off. Okay? You guys all have electricity at home, don't you? Yeah, everybody does? Yeah. These kind of wires up here, that's not what brings it to your home. It's usually under these gray, what we call tubs, transformers. And it comes out of the bottom of these, runs into the house, just like this. Now understand, all these examples today are things that can happen or have really happened to people where they've gotten burned, shocked, or killed, okay? And that's why I want you to be safe. Even the electricity that comes out of the bottom of these transformers into your homes is very dangerous, and that's why you've been told to stay away from it. You guys ever try to have a ladder leaned up against your house, maybe to clean some gutters out, maybe to paint, something like that, maybe power wash your siding? Well, ladders are dangerous around electricity because they're tall and they're awkward and they're metal. And all those things added together make it dangerous because let's say we've decided to paint the side of our house or we're climbing up the ladder. We've made it okay with the ladder, but we didn't pay attention to that wire going into our house. And look at there. There it goes. We just got shocked again. And that's why it's important to keep away. Now, normally, these wires are what we call insulated or protected, but sometimes that insulation rubs off, and if they're bare, they can shock you every single time you touch it, okay? Some of you might have a pool at home, and sometimes you clean the pool with a pool skimmer, and we're gonna raise our pool, see it there? Raise our pool skimmer to try to get the leaves out, and we get it too close to that power line, and look at there. Now, talking about pools in water, did anybody see that person standing over by the tractor light up as well? See that? He's not getting shocked, is he?
Yeah, he is.
He must be, huh? Why? Light's going on, right? Well, let me tell you how electricity acts when it hits the ground. Remember, it wants to get out of the wire, down the pool skimmer, through the person into the ground. But once it hits the ground, since we're talking about water, has anybody ever thrown a pebble into a pond before? Yeah. Or maybe tossed something in your pool? When that happens, what's the result? The rock hits the pond and a ripple starts. And the ripple goes out in all directions and it gets bigger and bigger as it goes, right? That's the way electricity reacts when it actually finds its way to the ground. It goes in a small spot and then it ripples out all the way around. So that anything or anybody standing around that can get shocked as well. And that's what's happening to the guy standing by the tractor. The electricity has gone into the ground, look there, and it's rippling its way over to him. And so it's not just dangerous for you if you were to get into the wire, but anybody else standing around as well. You understand that? Okay. See this big thing on top of the house here? It's what used to be known as a television antenna. It's in the days before cable, before satellite. When television came over the airways, we used to have these on our houses all the time. And it was a way to get television channels. And so what you did is you would plug a wire from this antenna into the back of your TV, and you could pick up television channels. But the problem is they had to go high on the house to receive the signal, and they were very awkward, and sometimes the wind was blowing. So we got somebody here with a wire to hold it and someone with a stick trying to keep it steady. But sometimes it was very hard to do so, and you would lose control of those antennas. And look at what happens. See that? As the antenna falls, it makes connection with the power line. We'll stop the arc there. And you can see it's lit up. Now, are both people getting shocked? Light's on, isn't it? And somebody's home. Look inside the house. You see that in there? I'm sorry for you all way over there. You might not be able to see very well. But there's a light lighting up inside the house. I told you electricity is afraid of heights. It wants to get down to the ground and it'll use the path necessary to get there. But not just one, not just two. It'll use any and every path possible. So what's happening here is it's leaving the wire, going through the antenna down this rope, it's got him, and it goes down the antenna and through this rod, and it's got her. But remember, this is plugged into the back of the TV, right? And the TV's plugged into a wall outlet, right? And so that electricity is traveling all the way out of this wire, down the antenna, and the cable plugged into it, into the TV, through the TV, back out the power cord plugged into your wall, and that's what's happening down there. It's just lit up the whole house, maybe burned up all your wiring, and maybe set your house on fire. That sounds pretty dangerous, doesn't it? It is. It's electricity, and it brings a lot of good things to our lives. Light, heat or air, gaming stations, television, phone chargers. But it's so very dangerous, and we want you guys to know some of the dangers because all these things have happened, okay? Just a few more examples and we'll get to some questions, okay? I want you to know that not all, so you're aware of all the dangers, not all of the electricity flows through lines suspended in the air on poles. Some of it, nowadays especially, it's buried in the ground. And that's what this tractor's about. You see that down there? Let's say it's a beautiful day out, it's nice and dry. It's coming on spring, and so you want to plant some trees in your yard. So you get a big tractor with a hoe on it, and you begin to dig in your yard. And as you dig down in, you didn't call to see if there were any power lines down there. And you dug deep enough, and look at there. The power running through that, the electricity through that cable is the same as what's up here and just as dangerous. And so that's why it's traveling all the way through the tractor and to the man standing on the ground touching the tractor, okay? Now let me ask you a question. Just a yes or no answer is all we need. If this man was sitting on the tractor, would he be safer? Yes or no? Yes, raise your hand. No, raise your hand. Okay. Let me suggest that in most cases, he would be safer if he was sitting on the tractor. One word answer. Can anybody tell me why? Just one word. Yes. Yes. Exactly. Rubber. He's got it. Because rubber, and you guys have probably learned this in school by now, rubber is known as a what? Insulator, right? And that simply means that electricity doesn't flow well through rubber. And so what would happen here if he's sitting on the tractor is electricity would come into here, it would go all through the tractor looking for a way to get where? To the ground, right? But it would come to these rubber tires and it'd say, oh, I can't go that way. So it would kind of just float around on the tractor and not go anywhere. And if the connection was broken, he would be okay, right? Let me give you another example like that. See this Jeep down here? They've decided to go for a sail on the lake. We have a big boat mast there. And so, not paying attention, they've begun to back this boat into the lake for a nice sail on the water. It's a beautiful day. But we're backing into the boat, or into the water with our boat, and we get too close to the power line with the mast, and look at what's happening here, okay? Electricity's leaving the line, it's going down the boat mast and through this stick into the person who's lighting up, and it's made its way to the ground, right? Now, is the person in the Jeep lighting up, yes or no? No, right. Can anybody tell me why? One word answer, yes. Rubber, that's right, the rubber on the tires, because it's leaving the wire, it's coming down through the boat and the hitch and the Jeep, it finds its way to the tires, can't go that way, so I'm gonna go back. And here is a path to the ground through this man standing on the ground. But this guy in the Jeep, he was okay because the rubber was insulating the electricity from going to the ground that way, okay? You see that, right? So as long as he's in the Jeep, he's safe. With that in mind, let's say, and we forbid that this would happen, but let's say you're in a Jeep wreck one day. You're driving along, and your car hits one of our poles, and the vibration from the accident breaks one of our power lines, and it falls down on your Jeep like that. Now, the line is broken. Is it dead or is it alive? Which do you think? Just go ahead and say, dead or alive? Alive. You guys are pretty confident. Maybe you've seen this before, huh? Yeah. I'm going to show you that it may still be alive. Just because a power line's broken does not mean the electricity cannot flow through it. Watch this when I let it hit the ground, because it wants to get to the ground, right? I'll push my button. See that? It swipes the ground, and every time it hits the ground, the electricity flows, right? So know that if that line's resting on your car, it could still be alive, right? So if the wire was laying on your car and you'd had a wreck and you're sitting in there with a live power line on your car, you should do what? You should stay in the car. Because as soon as you step out and you turn around, your foot's on the ground and you try to close your door, you've now become that path to the ground, right? As long as you stay in the car, the rubber's going to protect you. So just stay in there, call one of us, and we'll come and we'll shut the power off and it'll make it safe for you to get out of your car, right? Now, talking about rubber and broken power lines, you can't really see that this one's alive or dead over there until we put it on this guy who's climbing the tree. Now, we won't see much of an arc because it's laying on him, but we'll put him up high, see if he lights up with another broken wire on the other side of the pole. Let's see. Can you hear it? It's got him, doesn't it? When it comes to rubber, that's the way we work on power lines. Let me show you from here. These are gloves that you cannot get, will not find, so don't try. I can't even get them. They're provided to us by our work, by the company, by our EMC, okay? But they allow us to work safely with electricity while it's still on. Underneath the leather protector is a rubber glove, very thick and safe rubber glove. And I'm going to show you rubber is an insulator, right? And electricity doesn't flow well through it. So let me put it on and we'll see if we can create an arc with this guy right here. I'll grab the line while it's dead and we'll make it hot. Now watch this. See that? Now I can't feel that because the rubber is protecting me because it's an insulator. But you can see the power line is alive even when it's broken and I'm protected, okay? So let's put it down on him again. All right. So let's say a storm blows through and it knocks down all the lines and one's laying in the driveway. Should you go get it out of the driveway so you can make it to school? No, you shouldn't. Exactly right. All right. So never assume that it's dead just because it's broken, okay? One more example, and then we'll take some questions. See the soccer ball over here? It's what we call a switch yard or substation. It's where a very high voltage electricity comes in, and it's tamed down a little bit to go through our lines to your houses. But that someone kicked a soccer ball into that switch yard over there, and as they've gone to retrieve it, taking a stick with them, and as they swing that stick, they get into one of those bushings on that big green transformer. And as they swing that stick, ooh, boy, that was a big one, wasn't it? That arc jumped over and got him. It's almost like lightning, isn't it? Do you know what lightning is? It's electricity, isn't it? Maybe millions of volts, but it jumps like that through the air. And there's another example. Electricity's trying to get to the ground and it's going to find a way, and the way's through him. That big transformer and this little gray transformer is just like this little green transformer. This is used for wire that's buried in the ground. And it is just as dangerous as that suspended in the air. You see that? That's why it probably says something like danger, high voltage, keep out, warning. Just knowing that at any time, in any place, you can get shocked by electricity. Even sometimes when you know a whole lot about it. And so, because it's a good thing, it's good to know what you can about it, because it's also a very dangerous thing as well, okay? I want to thank you guys so much for your attentiveness and for being quiet and paying attention. So thank you guys very much.